Hello everyone, today we're looking at Unit 6, Lesson 2, Applications Involving Similar Triangles. So we're basically going to continue our discussion on similar triangles, looking at word problems as how they relate to similar triangles. So our first example, to find the distance AB across a pond, a surveyor makes the measurements shown in the diagram. What is the distance across the pond? So we always want to first identify, is there a similar triangle here? And if so, what is the similar triangle statement basically? Okay, so when we look at this drawing, we can see that these angles in the middle are going to be the same. Oops. So this angle C is going to be the same here as it is here. So these are the same angles because they're opposite angles, which you guys would have talked about a little bit in grade 9, opposite angles being equal. And then also you have these parallel lines, which we learned about in grade 9, parallel lines, and you make all those different patterns. So this line here and this line here, these are parallel lines, right? Meaning that they have the same slope. So angles that form a Z pattern, basically the angles that's formed by a transversal. So they make a Z pattern, so like this angle makes a Z pattern with this angle here. So those angles are going to be equal to each other, so we're just going to write Z pattern. Okay, so we can say that this angle is equal to this angle, which must mean that this angle, and again we could see the other Z pattern, is going to be equal to this angle. Okay, so if we think about that, I'm going to redraw that big triangle so that it's oriented the same way as the small triangle. So let's redraw. And you do not have to redraw these. It's just an idea to help you kind of visually see how they're similar. So just think about if you were to take ABC and essentially just kind of turn it so that AB ended up down here. Oops. AB ended up down here and C ended up top so that it was oriented the same way as triangle DEF. So if I was turning it, I would end up with A here, B here, and C here. Okay, and the same idea, we can draw those angles. So we can see angle C are the same, angle A and E are the same, and angle B and D are the same. And I'm going to label all that information I had. So I know that CB was 180 meters. Okay, and we're trying to find the distance across the pond, which was side length AB. So we can see that the angles match. So if we were wanting to write that similar triangle statement, we'd say therefore triangle ABC is similar, and then we'd have to take a look at triangle ABC would be similar to triangle EDC. Okay, because those are the angles that are the same. Okay, so let's let X represent the distance across the pond. Okay, so we're going to set up our proportion here. So because the big triangles are unknown, I'm going to do the big triangle on top and the small triangle on the bottom. So my big triangle, I'm going to have X over, and the corresponding side for that is 120. And then another ratio I have is going to be the big triangle that has 180, and its corresponding side is just 80. So we can now cross multiply to solve. Okay, so we'll have 80 times X equals 120 times 180. Okay, 120 times 180 is 21,600. And if we divide both sides by 80, we're going to get that x is equal to 270. So we can say, therefore, the distance across the pond is 270 meters. Okay, let's look at one more word problem. Okay, Brian is 195 centimeters tall and can see the reflection of the top of a building in a puddle 7 meters away. So we're going to say that the puddle, we're going to draw a puddle, be here. Okay, so it says Brian is 195 centimeters, and it says that he is 7 meters from a puddle. How high is the building to the nearest meter if it's located 40 meters from the puddle? So from the puddle to the building, so this distance here would be 40 meters. So again, I'm going to redraw this small triangle so that it's oriented the same way as the big triangle. Okay, so that would put Brian over here at 195 centimeters, which I'm going to rewrite as meters. So we would divide that by 100. It would be 1.95 meters. And we would have 7 meters down here. So again, recognizing that this is our 90-degree angle, this is our 90-degree angle. So this angle and this angle are equal. And then these two angles on the top would also be equal to each other. Okay, so we're going to let x, we're going to put x here. Well, let's let x represent the height of the building. So we can write our proportion statement. So let's set up our proportion. Okay, and because our unknown comes from our big triangle, let's do our big triangle on top and our small triangle on the bottom. So our big triangle, we have x for the height of the building over 1.95, because that's the height of Brian that it's similar to. And that's going to equal, again, my big triangle is 40 over the corresponding side of 7. So we will cross multiply to solve. So cross multiply. We're going to get 7 times x equals 40 times 1.95, which is 78. And then we'll divide both sides by 7. So x would equal 11.14. So if we wanted to round this to the nearest meter, we could say, therefore, the building is 11 meters tall. Okay? So set up those proportions and then cross multiply to solve when you're given an application or word problem like this. That's all for your notes for today.